So, hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 178 and in this video we talking again about about the static keyword, but this time about static member functions. Alright, so the last video was about the variables and now we talk about the functions. So, but before we talk about the functions, there was this exceptions what I wanted to show you, that normally what we learned that when we declare a static variable member in a class that they have to be defined outside, and I said there are some exceptions, and one of this exception is this const here. And you can see this const here, it's actually very simple. When you see a const static, then you can define it in the class. You don't have to go outside to define it. In this example, what you see here, they defined only this const outside because they have not provided here a value, but you can see the first two, they provided an initializer, so they don't have to initialize it outside. And this is the first exception, and const, we already know what const means. Const means you are trying to make a variable not changeable, and if you make a variable not changeable, which means later you can't change this value, you have to provide it a value when you declare it, and that's why this is an exception. And the next exception is here, which we have not talked about. This is this const expression. This is also normally very simple, has to do with this expression, but we will talk about this later when we go into const expression. Let's skip this. And the next one was this inline, what I showed you, or let's say what I tried to show you. Where is this inline? Here. And I couldn't show you this one in my project last time. I wanted to make here a variable inline, something like here anywhere. I think I just copied this line here or something so. And then I said, okay, let's put it here. And let's put it here to this static part and make it inline. And in my case, it won't work not. And the reason for that was because, don't forget this one here. My version, my IDE is not updated. I still have not Visual Studio 2022, which has this new version of C++17. I have still the old one, and that's why it's not working in my case. So yeah, this is working too, this inline. But let's talk about the word inline again. I talked already about this word inline. We have to talk a little bit more in detail in later stages about this inline. But I said you this inline is sometimes used because they want not make a special call. Normally you would not use this inline. Normally you would just use this int, and the compiler will create this variable, and later it will, yes, define it and initialize it on all this kind of stuff. But when you make inline, then it means you want to do all this stuff here so that the compiler is not calling separately another call for this whole declaration process here and defining process and all this kind of stuff. And with other words, when you use this word inline, you are trying to force it. And now the point is the compiler is not permitted to follow your suggestion. It can, but not. And that's why we will skip this here. We have to talk here about what the compiler can do and not. And most time the compiler will just ignore your inline when it says, no, I don't care about your inline. My optimization protocol says this works not like you want. I optimize it like my optimization protocol, and I don't care if you say inline or not. And that's why we skip this inline. But we do have to know it is possible. You will see some people use this inline static as well. That's why we have to learn it, but later more in detail when we go and talk about this inline inline word here more in detail, right? But you have to know this inline is most time used to force to make the code exactly here, which is most time against that what the compiler want, because the compiler is using inline too, but the compiler has its own optimization protocol, right? We don't know it how as a starter. Later you can see it how there are not only one optimization protocol, because different compiler has perhaps different optimization protocols, and then the compiler will optimize this code behind the scene, which is best. And then, yeah, that's why we skip this kind of stuff right now. So what you have to know is this static variables can be declared, defined inside the class itself as well. But that's, like I said, it's an exception. But with const, probably you will see it inside declared when it's a const. Keep this const here in mind, because I said this const is most time used in classes, and your program, your class should create many const variables as well, because we learned that passing a class by reference, a const reference, means that many variables and functions can only access to const variables, something like that. And that's why we should consider const as well. And the other one we will talk a little bit more. So that was only a very short, brief explanation that we can use also definitions inside classes, but normally no, when we talk about variables, they are normally defined outside of the class. All right, with that said, I think it's time that we go to the functions. And the nice thing is we talked here most parts, and the function part is very little. So you can see here static member function, that is actually only this little part here. And when we read about this, the first line, it says, functions are also not associated with any objects like the variables, which we talked. And what I mean with not associated with object means they can be called. So for example, if you make here a static function, they can be called like this variable here without an object. That means it. So in short, when you read something like that is not associated with an object, means we can call this function without an object. With other words, without a variable. Normally we create a variable, we want to use this variable, we make this type, the class is the type, the variable is the variable which we want to use, and then we have normally access. But if you read something like that, it means just we don't need to create a variable, you can just call it. And that was the new thing and the new confusing thing what I told you, but it's not so confusing when you get when you consider this one. And like I said, the static is an exception here. We have to learn this one time, and when we know all time when we talk about static, it means just it is considered a class. All right, let's go on here. When called, they have no dispointer, and this is also interesting, because we learned when we create an object, for example, any variable, the compiler is creating automatically this dispointer when we talked about this. And in this case, there is no dispointer. So there will be not created a specific dispointer where it points to the static member variables. And it is treated differently here. That's it. That's very simple, I think. And let's see, let's go on. I think that's not too difficult, but I make here in a moment some examples which are a little bit, we will see. So here, static member function cannot be virtual. We have not talked about virtual, but this is important. Const, we have no, what volatile means, again, a compiler thing, which we have not talked too much. And ref qualified, this is interesting. So member functions, when you hear member function, means just functions, normal function which are in classes, these are all-time member functions, then they cannot be const and ref qualified, which means here is my house class again, and you can see we can create here this variables, this other one, they can be here ref qualified, we have here ref qualifier, we have here a const qualifier, and when we create now functions, we can make this kind of stuff too, right? With a return type. So when I create here a function, let me copy this one here just for demonstration purposes. Copy, paste, and let's say I have here a return type, for example, int. And when I have here an int, for example, I can't use with a static keyword. When I make here static, a function, now it becomes a static function. I can't use this const const here, for example. It's not possible, but let's do what it says here. I don't know. Let's make here 23. And then here something else. Relative specific object, yeah. This one is, again, we can't use this. But here more important is, I think you get the idea, right? So the return type, we can't use with the return type const reference, we can't use reference, and the other we have not talked. But here in a moment more, I will make real examples. That was just for demonstration purposes, that you see what I mean. So we can't use const, we can't use ref qualify for static member functions. Let's see. The address of a static member function may be stored in a regular pointer to a function. Okay, we can store it in a normal pointer to a function, but not to a pointer to member function. All the time when you read this member function, it means a function in a class, and this one is a normal function, which means a function not in a class. Just remember this, makes it easier, and that's it. Then now let's go and make some examples and try to understand this a little bit more in detail, right? So to make an example, I have created here a new class, and you can see I called it here class like all time, and then I called it pure static class. And this word pure static class I intentionally choose because you can see in this little class, I have no constructor, I have no variables. Let's kick this out for a moment too. Let's make nothing here, just one variable, one function, and you can see this static int variable I have defined outside because I have to define it outside. We learned this in our last video, right? And only if you are using a const here, then you can define it inside. For example, if I don't want it outside, I could make a const, and then I could write here any number. You can see now it's working, and this one is now saying anything else. Declaration, what it says here, declaration is incompatible with const. Yes, this one is just say that I changed the signature. That's okay, but I don't want a const, but it was just for demonstration purposes. We know we can do this, and we could use inline too, but careful, inline means we have to think a little bit more if the compiler is really using this or not. And yeah, with that said, that was the variable. And I have just here one more function, and it is what? It is just a static function. And important here, a static function is the keyword static is here in front. So why in front and not why here behind? Because there is no return type static, right? Because you are putting it here static, and the return type is separate from this one. This has nothing to do with this return type. All right, this is a static function, but we can test it. What happens if I put this static function here? Is this working? And we start. So you can see it says anyhow no, at least here. Okay, let's do this one here. That's not true actually. Why is this? It's all right. The reason for that is another reason, not this. This one is possible. Sorry for that. I have to make this one here. You can see what you read this error here, right? What is the problem? Read it here and try to understand it. It's very simple actually. So I solve it. The point is, this is a class. It's called a pure class. And what was the default access specifier when we have not specified access specifier? Yes, it's private, which means I have no access to these variables here. That's why I can't access it. I can't call this class. All right, which means how I can make it access? Very easy. Access specifier public. Now, this one is accessible. And now I can show you that this one here is possible too. I can write it here or here, but careful, this static has nothing to do with the return type. That's very important because this one says only this is a static function, not a return type, because sometimes we have this const here, right? This const is related to the return type, but we learned we can't use const with static. Careful about this one. When we use static, we can't use const. We can't use reference or something like that. So we have never be It will look all time static and the type, and that's it. So that's how to create a function, and you can see it looks like this. And we see here something new. What is the new? Or let's say we see something what we know. And then what we know is we can define a function in our class. So we can't define a variable in our class, so we have to use it outside, but a function, we can define it in the class. That's possible, but normally you will not see this as well. Normally you would see it outside of the class, but like I said, when we talk about header files and CPP files, then you will see that they declare all things in the header files, which means they make here just declarations, and then they define most time all the other things in the CPP file. This kind of stuff they put in the CPP file, but later more when we talk about this header and CPP files, when we are in the section. All right, but the important part is you have to know variables must be declared outside or have the special exceptions with a const and inline or const expression or whatever, but normally outside declaration. And functions, no, they can be defined inside, but you will see them most time also defined properly outside in the CPP file. So which means let's make here a comment C, and then it makes a declaration, and then you just define it on the outside like so. And you can see what I have to do. You are skipping again the static word when you define it outside. You just take here this int, because this is the let's say this real signature. You have just the return type, which is int. Then here the class, because you have to specify where to find the static function here. And you say, okay, the static function is in pure static class. So and then the resolution operator, and then you define it outside. All right, that's good that we learned here the variable outside definition. That's also nice. And you can see that's working both ways. All right, so we have this. I hope you understand this. It's not very difficult. It's very easy so far, I hope. And yeah, the next point is how we call this. So I have here my little class. It's very little, and you can see I have skipped here many things. I have not here a constructor, but we know when we have not provided a constructor, what happens? Yes, the compiler is providing for us a default constructor. We know this. And yeah, and this one, you see I have poorly, yeah, I made almost no comments like here. Here I have made it very nice. Variables here, then the public specifier, functions here, and then here the public specifier to print it out more, and then here the constructor and so on. And you can see here I skipped here a lot of things, and in general in coding you will see it probably more like this one, and the reason for that is they will only specify when they need it. For example, in my case here, okay, this one must be public. I want to keep this static. And then they will just skip here to say this is private, because you should know this is private. They will skip also the constructors, because you should know there is a default constructor and all this kind of stuff. But let's go on and discuss now one more thing, which is how we call this function here. We know this, how we can call this. There are different ways, and let me show you this way. This way we learned the last time. What is this way here, what I show you here right now? It starts with pure static class. Okay, the pure static class is our class name. Then it goes to this resolution operator. Okay, we know what the resolution operator is. The resolution operator says, I will try to find this one here, this function here, in this pure static class. Okay, and it says I go here and I indeed find it here and I will call it. So you are trying, what I do here is I just try to call a function again without an object. That we learned in the last video, and that's a little bit the confusing part in C++ when they talk about classes and objects and instances. And because when we use static, we don't need an object. So that's very important, and that works also with functions. So you can see I can just call the function just with the class name, no object created before, and just call it directly, which means that's a little bit strange, right? So I can call it and it is printing out an error. What is an error? Return a value, all right. Yes, I have here not forgot to return a value. Let's take the value here. Copy this one outside, and of course, because here I have an int, I should return a value, and static variable here. Is this okay? I think this should be okay now. Now I'm returning a value, and we have here now indeed a value 5 and 44. What's that? Ah, that was this other one. All right, so we have returned here a value because now I'm lazy. This one is almost the same like here. Here I have some spaces. Let's copy this one here perhaps to make it absolute the same. All right, now that's the same like before. Now let's one more time. So important is here's the number 5 and 45 is for the other call here, which we learned in our last video. Here in the second line, I just print out this my static variable from my other class. You can see this is the big house class from the last video, and I created here the static variable, and you can see here again, I have not created an object, a variable, but I can access it just with the presence of a class. And that's the new thing which we have to understand. Here I have just a class with static variables or functions now, and I can call this function also without creating an object. But keep in mind, you still can create an object and call it the normal way as well. So for example, normally what you would do is, let's say here's my pure static class, and let's say I still create an I don't need an object. Let's call it I don't need, oops, let's make it so I don't need an object, but I create one. All right, I don't need an object, but I create one. All right, I don't because here the constructor, you can see it's a default constructor. That's why I can make it this way. It's fine. And now I don't need I can use, of course, my variable name, which is this one. And now I can call here the static function, for example. Let's call it. And yeah, let's see what happens. And there is the 5. I can call the static function, but we have here something interesting. What was interesting? I could not call the variable, but careful. Why you can't call the variable? Again, access specifier by default. You can see the access specifier public starts here. Here I have not specified the access specifier on top, which means this one is private. Of course, I could call this one too when I make this one as well public. Let's make this one as well public. And now I would call also the variable here because it pops up now. Let's go here. Point, and now you can see I have access to the static function or the static variable, what I want. This is the normal way, right? This is the normal way what we learned. We just get the class, then create a variable. Normally we would call a constructor, but here it's I'm using the default constructor. And now I have created this object, then I use the object, then I use the access specifier, and then I try to access that what I want, and then I change it. But with static variables, and that's the new thing, let's make this one, erase it, we don't need it, and this is a little bit confusing. I mean, confusing in the sense of many programmers expect, for example, an object, right? So normally they see here something like this and say, okay, where is the object here? And important is to understand this here, that you hover with your mouse over it, and when you read static, right, you can, when you hover with your mouse over this kind of stuff, then you can read static. When you ever read something with static, you have to think, okay, static means I can call static objects or static variables directly. But careful, only static objects and static variables, not non-static objects and non-static variables. And now we have discussed about this one. And here the same thing. You can see again static. Static means I can have an object, but I don't need an object. I can call the class directly. You can see we have here a namespace. We have here a class. And now this resolution operator is just calling what's inside the class, in this case my variable here, my static variable, directly without an object. All right, I hope that makes sense so far, because now I want to show you one more thing about classes, which I mean functions, which is very important, which is this function here cannot use non-static variables. What I mean with non-static variables, I told you that's very important. In C++, they differentiate these non-static variables like I showed you here. These are all non-static. We have not the keyword static, and then we have here this keyword static, right? Variables. And the same goes later with functions. They are non-static functions, and if they have this static word function, then they are similar like this one here with static. And you have now to differentiate this two. You have to understand this, because that's very important. And here is, like I said, there is one more important rule, is the static functions here, they cannot call non-static variables. What I mean non-static variables means, if I create here a normal variable, I call it all time normal variable, but the real word is non-static variable. Let's make here int my telephone number, and I can assign, of course, a telephone number here. But if I want to use now this my telephone number here, for example, return my telephone number, right? I want to return my telephone number. Here's my telephone number, and look what happens. We have an error. It says a non-static member reference must be related to a specific object. And that means if you want to use a non-static member, then you have to create an object. So let's see. If I created an object, can I make this with an object? We can. Okay, this one will not work. But you get the idea, right? So I have to use with static function. I can only access static variables and static functions. That's so the idea. For example, here, this is static variable. This one I can return here. Static variable. Yes, here is no problem. I can return. And if you want to call in this function another static function, you can only call another static function. Let's make here a non-static function here on public. Let's delete this one here. It's irritating a little bit. Let's make here in again a normal function, void non-static function. All right, let's call this just we don't even make something. It's just okay if I have nothing in here. I want only demonstrate it. I can't call it. What I mean with that, here in my static function, I can't call it because it's not static. Let's call it. Let's try non-static function. Here's the non-static function. And here I have my parentheses and I call it, and you can see again, it says a non-static member reference must be related to a specific object. This is not possible. That's so the last rule which we learn in this video, which is if you use a static function like I did here, it can only call static variables or static functions. So it's only working with static values. That's very important to know. And yeah, and before I stop, let's make here a pane to I try to make it where for beginners, let's see, to make it very simple. Actually, it is very simple when you think about this. Let me show you this. We make here two blocks. One block is the class. One block is the object. And let's write here, when we have static, when it's static, it's all time connected to this class here. Let's write class here. class can only work with the class here, and here let's write here variable or object. Let's write here object. Let's write here object. I have right. Anyway, you will see it. And the point is now, actually you have just think very simple, not to overcomplicate it. The point is now, if you see this word static anywhere in the class, right? So here is a static and static. It means it is only connected to this class here, and actually to both. Not to only to static, but it is working with this class. And we learned what I mean is connected is, yes, it behaves like it belongs to the class, not to the object, because this static can work without an object. You don't need an object, and that's, yes, that's more or less the thing what you have to understand. This is yeah, this is the thing which is a little bit confusing. That's also not a super diagram, but the static, what I want to point out with this diagram is I don't need this object to call a static function or a static class, but I can have an object. So I don't need, but I can have still this object. So still possible to use it. And that's the example here above, right? You can see here, before I made an example with an object, you can use it, but you can just call the class itself and then the static function or variable. You can see here we have a static function call. Here I have a static variable call without an object. Here this object is not present. This object is all the time a variable in our case, right? When we create a variable, let me show you this again, what I mean fast. Here when I make a pure yes, variable, let's call it yes, object for this object, let's call it just object here. So you can see, and normally I can use this object here, object, and then I can access, and then I can see whatever. I can do this normally this way, static variable, or yes, it's not calling this. Call must have. Okay, that's not so important right now, but you get the idea, right? You can have this one here, static function. Here's the static function. All right, and then you can have this static function here with, and here, this is the diagram. Here you can have it with object, so the normal way. Here, class, you have first your class, this is this part here. Then you make your object, that would be this part here. Then you can call with the object the static function. If it's in, it's possible, but you don't have to. So when I say you don't have to, means I can just kick this out here, and now you can just use it without an object. And this part here, this using without an object, this is a little bit confusing in many programmers, because they say you need all-timer instance, or that's most programmers say you need all-time object and you need an instance and all this kind of stuff. No, this is an exception with the static. The static, let's say it breaks this rule, right? Normally you would work with object. It makes it much easier to work with an object. You just create, like I said, you just create a variable, and then you use this variable, you send this variable, you change this variable, and it's absolutely easy. But this here is really breaking a little bit the rule, because normally you say, hey, where is the object? Where is the variable which I use? No, it is the class which you are using directly here. And like I said, you hover your mouse over it and check what you have here. If it says static, then you have to think, oh, static is an exception. Static behaves different than normal. And there you don't need an object, which means I can call it by the class, because static is connected just to the class. And like I said, you should read this again in a good C++ book. And we will concentrate more on the practical use case. like you can see here. And the last note, what I want to say here is what? Yeah, why I called this here a pure static class. A pure static class would be when I delete this one, which means in this case, a pure static class means I don't even have to create an object to use this class functionality. So I can program here all the functionalities when they are all static without using an object at all, and still may print out some useful code here. And that's yeah, that's interesting. And still, like I said, that's a little bit the point when people get confused. There is no object and still you have full functionality. For example, if this static variable is here, let's make an example here. I need here, what I need here, static function. Here's the static function. Let's kick out this non-static function because I need all in static. Okay, now all is in static, and let's make this variable definition is, let's set it, for example, to 0, start with 0. And here what I just do is perhaps I can print it out, but let's say I increment this static variable again. Very simple. Copy this one, paste it, I increment it, and now I call this one here, the pure static function here, let's call it perhaps 2 times more. Let's copy this one, let's call it, and let's see what happens. And we see here, you can see I have here this number 1, 2, 3, and you can see this numbers here, this static variables here I can use, right, for functionality without creating an object at all, just using the class. So when you have just access to a class which has static variables, static functions, that's one another use case. But before I close now this tutorial, here one more thing. You should avoid static. Not because it's bad or something, but static, like we discussed, has class access, right? Class access means, like I showed you here, when anyone is creating an object here with this class and another person is creating a class, like I showed you here in my last video. Let's show this again, uncomment here. You can see here that was with my big house class. This is the other class. Here I showed you that when, for example, I create my big house, I create a coder's house, which is coder. Then Maggie is creating else an object, a variable, Maggie's house with Maggie. And Maggie is changing a static variable. This static variable is changed as well in coder's house. And that's why you should try to avoid using static variables, because they can, if you are not careful and you don't know where they are all implemented, destroy other code or change other variables. And that's why they are used in certain cases. They are really nice use cases, but most of the time they are not used. And which means most of the time you should try to avoid this. Only make this use of this functionality when it makes sense and it gives you easy access and so on. Most time it is more confusing because, like I said, you are not creating an object. You are directly access the class. The class is shared with the objects, like you can see here. And when one is changing a static variable, the other's static variable is changed. And when he is using, I don't know, the coder is now using this static variable, but Maggie changed it here on its own, then his is changed too. And when he used this my static variable anyhow, where he expected it would be, let's say, the initial value where it was 54, then this can break easier code. So careful about static variables, static functions. They have very special use cases where it's absolutely nice to have them because they can save a lot of work in special cases where you won't share information between classes. We have to talk this in another video, not at a starter video. But general rule is we have to understand what static variables are, what static classes are, because you will see in future definitely static functions, static variables. And careful, one more thing, these are only in classes. Don't mix them with static variables outside of class. We talked them briefly. They have a different behavior outside of the class. That's why this word static is a little bit, not so easy, but after you learned this, you will get better and you will understand it. So with that said, I stop here. That was, of course, you should read in good C++ documentations and good books to understand this more in detail, and perhaps watch also more examples where they explain this. But the biggest thing is that you understand the static keyword is connected just to the class. We don't need an object. And of course, all the behavior rules, how they behave in a class and how they behave not in a class, because the static has another behavior outside of a class. We learned this also, right? All right. With that said, I stop this video. I hope I confused you not too much. If you have any questions or any complaints like old time, write it in the comments below. And see you in the next video. Bye, good luck, and like old time, don't give up.